Okay, in this presentation we're going to look at a sports science example for inference procedures. So what we're looking at is the difference in means between two groups. And here we have a sports science example where we have two different types of exercise. So an exercise physiologist wants to determine if several short bouts of exercise provide the same benefit for cardiovascular fitness as one long bout. Okay, so several short bouts, one long bout. So we have 50 volunteers randomly assigned to group 1 to do a standardized aerobic exercise on a stationary bicycle for 30 minutes once a day for 5 days a week. The second group, 40 volunteers, are randomly assigned to group 2 and do the same exercise for 10 minutes 3 times a day 5 days a week. Okay. Cardiovascular fitness was measured by VO2 max, which is maximum oxygen consumption when exercising. Okay, so group 1, this is it in a nutshell. The mean change in VO2 after 12 weeks of exercise was 2.1 for group 1 with a standard deviation of 1.7, and for group 2 after 12 weeks of exercise it was 0.7 with a standard deviation of 1. So test the hypothesis that there is no difference between the two groups. And so so essentially this is the hypothesis test. Now this question goes into a lot, breaks it up into small chunks, but essentially what we're doing here is a hypothesis test, and what we're using is a 5% significance level as well. Okay, so just to sort of make that clear. Now, just as a quick remark, actually, something I should sort of state is that we're going to assume that there's equal variance between the two groups. 1 and 1.7, that's 1 and, so essentially that's a sort of requires a bit of a leap of faith there, maybe. But essentially, I'm going to sort of assume equal variance, which is a necessary requirement in this particular case. But we'll sort of look at that in another video. So for the time being, we're going to assume equal variance, and in another video we're going to show you how to test that. So in this case, what we're going to do is follow this four-step procedure for hypothesis testing. Okay. If you want to take a look at that and have a quick read of that, you can just pause the video. So essentially what we're specify the null and alternative hypotheses. So the null hypothesis proposes no difference in VO2 max levels. Okay, just a quick sort of statement like that, with what is told to you in the question. Just a sort of quick statement like this. It depends from question to question what you get, but just a quick sentence there about what you're being asked to do. And you'd accompany that with a formal statement of the null and alternative hypothesis in terms of the population parameter and in mathematical notation. Mu1 is equal to mu2, that they're equal to each other, that the VO2 max levels are the same for both groups after 12 weeks, or they are not equal to each other. Now, what you can also do is express that in terms of the difference of means there. Sorry, there's a couple of typos there that I thought I fixed from another video, but doesn't matter. So mu1 minus mu2 is the difference in means for the population. So essentially, this is saying, is there an effect is there an effect due to the treatment type? And if there's no effect, that means mu1 minus mu2 is 0. That ultimately it makes no difference what you do. So that's how you might sort of state it there. And what you would get in this case is that you would explicitly state the expected value under the null hypothesis, the expected value of the difference in means under the null hypothesis, which is 0. Now, also what we have is a two-tailed test, okay, with a significance level of 5%. A two-tailed test because we have equals versus not equals here and here, okay. So I won't go into that in too much detail as to why that's a two-tailed procedure, but it's important to pick up upon because that is relevant for when we go to the critical value. Now, this is the main part of the procedure in terms of number crunching. This is the calculating the test statistic. And the first part of that is calculating the standard error. So what we're going to do is use this formula here. Now this is based on the sample variances and the sample sizes. Now we're told the sample standard deviation, so what we have to do there is just square them. Okay, 1.7 squared over 50 plus 1 squared over 40. Actually, do you know what? I'll just double check to see if I have that right. So it is 50 and 1.7 and 40 and 1. Okay. So I just realized I could have really got myself stuck there. So yeah, that's correct. 1.7 squared over 50 plus 1 squared over 40. That's using this formula just above us. Okay. The square root of 0.0578 plus 0.0250. That is the square root of 0.0828, and that gives us 0.2877. Okay, so the test statistic is the next part here. So we actually calculating the actual test statistic, and the test statistic is a normally distributed random variable distributed according to the standard normal distribution with a mean of 0 and a variance of 1 squared. Just make a quick statement about that. Don't write in TS. Just say what it is. This is the general structure here. It's the point estimate minus the expected difference in means of the null hypothesis divided by the standard error. Now, just as a quick remark, the point estimate is the difference in the means. Okay. The difference in means is the difference between 2.1 and 0.7, which is 1.4. So that's what we observe as the difference in means. So there we have it there. Let's go back there. So our test statistic is 1.4, which is our point estimate for the difference in means, minus 0 divided by 0.2877. So our test statistic should work out to be 4.86. 4.87 is fine, something like that. Okay. Now, the critical value is the next part here. So I'm going to cut through this very quickly, just to suffice to say we have a significance level of 5%. We have a large aggregate sample size. It's a two-tailed procedure. So piecing that together, and if we look at our statistical tables and using that information the correct way, 5% large sample, two-tailed procedure, we should get a critical value of 1.96. Okay, so I won't dwell on that any longer, because if you're not sure where that's coming from, this is the wrong video to find out. Now, so let's make our decision, and the decision is as follows. We either reject the null hypothesis or we fail to reject the null hypothesis based on based on the decision rule we're about to employ. Okay, so is the test statistic greater than the critical value? If that is the case, then we reject the null hypothesis. That is pretty much the case here. Okay, 4.86 or 4.87 if you prefer. We reject the null hypothesis. There is enough evidence, there's definitely enough evidence, never mind that, enough evidence of a difference in terms of VO2 max between the two exercise regimes. Okay, so essentially there is a difference on your fitness depending on which of the two exercise regimes that you can take. So there's significant evidence of that. Okay, that's the correct conclusion, because really hypothesis testing is really about evidence. It's not about proofs. Okay, I think we'll leave that there.